Hello students, welcome to Saraswati classes, and we are going to study another oxidation reaction today, which is known as the Swern's oxidation reaction. What is it? You have an alcohol and you are using phosgene. Okay, not phosgene, this is oxalyl chloride. Okay, and then you have DMSO in presence of CH2Cl2. Temperature is very low. In presence of a base, you are getting the ketone. Next, what is the mechanism? So over here, as we can see, we are using trifluoroacetic acid anhydride, okay, and that is getting reacted with the DMSO. So this mechanism is very much similar to the previous one that we did. Okay, now over here the attack will take place on the carbonyl group. So this is basically a nucleophilic addition substitution reaction that is taking place. Now this is forming a trifluoroacetoxy dimethyl sulfonium trifluorate, and this is basically a sulfonium moiety over here, which is going to act as a Lewis acid. Now if you take the rearrangement, if you take the reaction little higher in temperature, so we can have the Prumerer rearrangement happening over here, and that should lead to the formation of this type of side product. Now that is not our concern. So this is the intermediate that is formed. Alcohol will attack over here. So obviously what we can expect is a cyclic intermediate being formed over here, and as you can see, the arrangement of the atoms are very much to generate a six-member transition state. Abstraction of the proton takes place over here. Okay, so this will lead to the formation of this type of a intermediate again, and the hydrogen that is there, okay, over here, this is now being abstracted by the base that is being used. Okay, so basically we are leading to the formation of a S plus and a CH2 minus unit over here. Let's see what happens next. All right, so for the mechanism of the Swern's reaction, as you can see, the sulfonium ion, it makes an attack to the oxalyl chloride. Again, another nucleophilic substitution, addition substitution reaction is taking place over here. So the O minus is coming back, Cl is acting as the leaving group. Cl minus will now make a attack on the S plus unit, and that will lead to the formation of a chlorosulfonium salt with the formation of a CO2 and CO. Okay. Now this chlorosulfonium salt that is being formed is getting nucleophilic attack from the alcohol, and this type of an intermediate is formed in which proton and chlorine are lost at the same time, leading to the formation of this type of an intermediate. Okay, and that intermediate is having a proton. Okay, as we saw in the previous slide, this type of a unit was there and this was being taken up. Okay, so this is basically activation of DMSO with trifluoroacetic anhydride. Here we are doing activation using oxalyl chloride. So that is the basic difference, okay, over here. Now this particular alkoxysulfonium halide that is being formed. Why it is called an halide? Because we have a plus charge on sulfur and a negative charge on CH2. Okay. So now That being the case, if you are using this DMSO CO2Cl2 in presence of dichloromethane, then the oxidation of this OH group will take place to lead to the formation of a CHO. Next, as you can see, we can also use this reagent in presence of cyclic ketones, and oxidation will take place on the OH group to form the CHO. Even BOC, which is used for protection of NH groups, can also be uh, there within the molecule, and the alcohol can be oxidized to the aldehyde group over here. So it does not disturb any protection. That is what it is meaning. Again, ether functionalities are over here, that is remaining untouched, and the OH group gets oxidized to C double bond O. Over here also the alcohol gets oxidized to C double bond O, but nothing happens to the 3-degree alcohol over here, as you can see. Again, we have a cyclic ketol, and if you're using the Swern oxidation reaction, so no cleavage of this ester takes place over here, but the double bond also is not affected, but over here OH group gets converted to the C double bond O. Similarly, OH group converted to C double bond O, but nothing happens to the silyl protection over here. Now over here we can see there is protection on nitrogen. There is a double bond, there is a ester, there is a amide, and if you're using this reagent, it will lead to the formation of an aldehyde over here. But in the second part of the reaction, as you can see, you're using the phosphonamalide, so obviously C double bond O that was here will be getting converted to an alkene via the Fittig reaction. Okay. Again, another example, we can see there is a ether. There is a ether over here. This is a 3-degree alcohol, so this will not be oxidized, but the 1-degree alcohol over here will be oxidized to aldehyde. Again, this thing we will do in the next lecture.